Section 13.4 talks about surface areas. It says students will be able to understand and explain surface areas of right prisms, right circular cylinders, right rectangular pyramids, right circular cones, and spheres. So we're going to talk about surface area of right prisms. The lateral area will be the sum of the areas of the lateral faces, and the surface area will be the sum of the lateral surface areas and the area of the bases. So let's see. We have, for our first problem here, the surface area of a cube. Okay, so when we're trying to find the surface area of a cube, the formula is going to be 6 times e squared, where e stands for the edge. Okay, so let's see if we can do the first problem here. We're looking for the surface area. So we're going to take 6 times e squared. So 6, the edge in this case, if you notice, because it's a cube, it's 10 centimeters squared. So this is going to be 6 times 10 squared is 100. Because we are dealing with area, it's centimeters squared. And then finally, 6 times 100 is 600 centimeters squared. And here is our surface area. So guys, I want you to notice something. We've already squared the 10 centimeters, and that's how we came up with 100 centimeters squared. So once I get to this spot, I'm done. I don't need to square the 600 anymore, okay? We squared the 10. That's how we got to where we are. All right. So for the right circular cylinder, the surface area is given to us by this formula right here. And it is 2 pi r squared times 2 pi r h. So I kind of want to walk you through that formula and so we can understand how they got there. Okay. So, excuse me. So this is my height and this is my radius, right? If we wanted to find, say, the area of the top and the bottom, well, I know the area is pi r squared for a circle, but we have 2 of them, so it would be 2 pi r squared. So if you notice, that's where that part is coming from, okay? Now, I want you to think about if I were to take like a pair of shears or scissors or something and cut that can kind of down the edge like this, and we were to unfold it, right? If we were to sort of unfold that, this here would still be the height. This circle would be this distance. Let me see if I can get a little bit darker. Would be this distance here. This distance here is the circumference of a circle. Remember, the formula for the circumference is 2 pi r. So if we were going to find the area of this rectangle, it would be 2 pi r times h. So 2 pi r times h. So we would take this piece here and add that piece there. And if you notice, that's exactly what they have right there. Okay. So just kind of wanted to at least walk you through that so you understand, where did they come up with this piece. Okay. All right. So let's see if we can figure out this next problem here. So I'm going to write down my formula. Area equals 2 pi r squared plus 2 pi RH, okay? Surface area, I'll go like this, surface area. So 2 pi, our radius in this case is 8 centimeters squared, plus 2 pi. My radius again is 8 centimeters, and my height is 15 centimeters. So this is going to be 2 pi, 8 squared is 64 centimeters squared, plus, I'm going to grab my calculator real quick. Let me move it this way. Turn it on, clear it out. Okay, so I'm going to multiply 8 times 15. So let's do 8 times 15. That's giving me 120. So 2 pi times 120 centimeters squared, because centimeters times centimeters would give me centimeters squared. Okay, and so 2 times 64, 128 pi centimeters squared. 2 times 120 is 240 pi centimeters squared. And now we're just going to add these two pieces together. So what is 128 plus 240 and I'm coming up with 368 pi centimeters squared. Okay. So one thing I want to mention about these problems, guys, is they take a little time to do. I don't necessarily think they're difficult, but they are time consuming. So as you're going through these problems, try to go slow. I try to minimize the amount of homework problems you have in this section just because they do take a little bit of time, okay? So now here's the next one. It's a right rectangular prism. And if you notice, there's no given formula here. But remember what we're looking for. We're looking for the surface area, okay? So when we have a cube or a rectangular prism like this, I want you to think about what we're looking for. We're trying to find the area of the whole piece. So I have two sides that look like this one here, and then that one back there, okay? So I'm going to just try to look at this piece here. If I wanted to find the area of this rectangle, this one right here, my formula would be length times width, okay? And I would have 7 times 6, which would be 42 centimeters squared. And because there's two of them, I would have to take 2 times 42, which would give me 84 centimeters squared, okay? So we found the area of sort of like the front piece and the back piece. Now let's see if we can find the area of the sides. So this is what I mean by the sides, okay? So again, I'm going to go length times width. And so let's see, we're going to take 6 times 3. That's going to give me 18 centimeters squared. And because there's this side and then that side over there, I'm going to take 2 times 18. That's going to give me 36 centimeters squared. Okay. And now let's do the top and the bottom. Okay. So here's the top. Okay. Well, I know that this piece is also 7, that piece right there. And if this is 6, I know that's going to be 6 too. And, oh, you know what? Oh, let me see. Did I mess something up? Yes. You know what? I did the top and the bottom earlier. I'm sorry. When I was doing this, I did the top and the bottom because I was going 7 times 6, right? Okay, so this was sorry about that, guys. I just realized that right now. Top and bottom. And let's see. These here were the sides. Okay, so that was my bad. My mistake. So now let's do the front and the back. So this piece here. This is 7. This is 3. Okay, so length times width is going to be 7 times 3. That's going to be 21 centimeters squared. So now we're going to take 2 times 21 centimeters squared. That's going to give me 42 centimeters squared. Okay, so now to find the surface area, we're going to take 84 and 36 and 42, and we're going to add them all up. So 84 plus 36 plus 42, and that's giving me 162. So the surface area here would be 162 centimeters squared. Okay. Okay, so here's my next formula. We have the formula for the surface area of a sphere. Excuse me. And the surface area of a sphere, the formula is right here. It's 4 pi r squared. So I'm going to write down my formula. 4 pi r squared. So 4 pi, my radius in this case is 8 centimeters squared. So this is 4 pi times 64 centimeters squared. So let me take my calculator. What is 4 times 64? And I'm coming up with 256 pi centimeters squared. Okay. All right. So here's the next one. The formula for a right circular cone is given to me right here. Okay. And we're going to see if we can't figure out this problem. So first thing I'm going to do, I'm going to write down my formula. I know it's right there. But when I write it down myself, guys, it just feels like it is easier for me to understand. Okay. All right, because now what I'm going to do is plug and chug pi. What is my radius? 15 centimeters. Okay. Times my radius again is 15 centimeters plus, let's see, the square root of the height, in this case is 20 squared, plus the radius squared, 15 squared. Okay. And let's see, I'm going to write this as 15 pi times 15 centimeters, 15 centimeters plus, I'm going to do this part here on my calculator. Okay, so let me take my calculator and I'm going to type in this piece right here, guys, exactly as I see it. So here's my calculator. Let me clear the screen. So I'm going to go second square root, because that's what I see. And I'm going to type in 20 squared plus 15 squared. Okay, close off my parentheses and hit enter. And that's giving me the number 25 centimeters. Okay. So now 15 pi centimeters. 15 plus 20 is 40 centimeters. Okay. So now let's take our calculator again, and we're going to take 15 times 40, and that's giving me 600 pi centimeters squared. Okay. So again, it takes a little bit of time to do it, but I'm going to go really, really slow and make sure that my answers are coming out the way I want them to, okay? All right, so here's the next problem here. It says, assume the radius of a certain planet is 4,840 kilometers, and the planet is a sphere. What is the surface area? Okay, so we got a planet, right? Looks something like this. Okay, and here's my radius. And we know that that radius is 4,840 kilometers. We are looking for the surface area. So I'm going to scroll back over here. We have a sphere. Here's my surface area formula. It's 4 pi r squared. So I'm going to write 4 pi r squared. So the surface area is going to be 4 pi times 4,840 kilometers. We're going to square that. So let me grab my calculator. So I'm going to type in 4840, and I'm going to square it. And wow, huge number, right? And I still got to multiply that number by 4. So let's go ahead and multiply it by 4. So I'm coming up with 937. And what was the rest of it? 02400. 2400. So that would be 937 million. Wait, I forgot. I put my comma in the wrong spot. Let me see. Oh, come on, pen. Sorry, guys, my pen is freezing up. There we go. Okay. So 1, 2, 3. Here we go. 93,702,400 pi kilometers squared. And that would be my surface area. All right. So let's see. It says the top of a rectangular box has an area of 42 square centimeters. So let's start drawing the top of a box. Okay. So here's the top of the box. I know the area here is 42 square centimeters. And the sides have areas of 70 and 60. So what do we mean by that? We mean that one of the sides here, the area here is going to be 70. And this one over here is going to be 60 centimeters. We are looking for the dimensions of the box. Okay, so we're trying to say we can find the dimensions of the box. So now I got to kind of see if I can figure out what's gonna go on here. Okay, so if I look at the top, I know the area of the top is 42. So I'm thinking about, what possible numbers could I use? I could use like 6 and 7. I might use something like, 21 and 2, right? I'm going to have a whole lot of possibilities. And if I look at the bottom, this piece here, the area of this piece, say the front and back, right here, front and back, is 70, right? So this could be something like 7 and 10. It could be something like, I don't know, 35 and 2. I'm going to have some options, right? And then I'm going to do the areas of the sides. And the area of the side is 60, so that could be something like 6 and 10, right? It could be something like this. So what I want to start doing is trying to figure out, okay, which ones have some common numbers here? Well, if we said the area of the top, sorry about that, guys, that was my email. If I said the area of the top, since we knew it was 42, if we said, say, this piece here was, say, 7, and this piece here was 6, that would give me 42. And if this piece here, I know my picture looks a little bit different, but if this piece here was 7 and this piece here was 10, that would give me 70. And if this piece here is 6 and this piece here is also 10, that would give me 60, right? So I'm just looking for these kind of dimensions. So the dimensions in my box would be 7 centimeters, 6 centimeters, and 10 centimeters, right? Those would be the ones, because we have these numbers in common in each of these cases, right? That's kind of what I'm looking for there. Okay. So the next problem we have here is talking about lateral area. So lateral area refers to the sum of the areas of the lateral faces. All right, excuse me. It says, suppose one right circular cylinder, cylinder A, has a radius of 7 and a height of 9. So before I do anything else, I'm going to draw this. Okay. So here we go, like this, like this, like this. You kind of get the idea. Okay, so we know that the radius here is 7 centimeters, and the height here happens to be, or 7 meters, I'm sorry, not centimeters, meters. And 9 meters, okay? And then it says we have another one, cylinder B. Okay, so we have, this is A. Then we're going to do another one, B. Okay. And we know that the radius of B has 9 meters, and the height here is 7 meters. This is B. And the question for part A says, which area, or which cylinder, has the greatest lateral surface area? So we're looking for the lateral area. We're just looking for the area of the side. We don't want the top or the bottom, okay? So remember, if we were to cut this can down the side and we were to open it up, right, it would be a rectangle. And we know that the height here would be 9 meters. This distance here would be the circumference of that circle, 2 pi times, in this case, 7. So the circumference would be 14 pi. So now we're going to find the area of this rectangle. This would be my lateral area. I would take 14 pi times 9. And so my lateral area, let me grab my calculator. Turn it on. What's 14 times 9? It's given me 126 pi meters squared. Okay. Now let's do the same thing for the green one. Okay. So I'm going to take a pair of shears or scissors or something, right? Something to cut this open. And let's see what this is going to look like. This is still going to be 7. Remember, this is going to be my circumference, 2 pi times 9, which would be an 18 pi. So my lateral area would be 18 pi times 7. And I'm going to grab my calculator again. I'm going to move it back this way. So what is 18 times 7? And I'm coming up with 126 pi meters squared, right? So look at the answer we got for this one, and look at the answer that we got for this one. So what would we know? we would know that they would both have the same lateral surface area. Okay. Now, there is a part B to this question. Part B says, which has the greatest total surface area? Okay. So we already know what the area of the sides look like, right? We now have to come back and let's say, well, what happens if we take the area from the top and the bottom part of those cans and add them in? Okay, we can do that. So if we're going to do the area for the top and bottom for this one, remember my formula for the area of a circle is pi r squared, but because we have two of them, it'll be, because the top and bottom is 2, we'll have 2 pi r squared. So I'm going to take 2 times pi, my radius is 7 meters squared. So this is 2 pi times 49 meters squared. This is going to be 98 pi, oops, hold on, my pen froze up again. There we go, meters squared. So now, when we're going to find the surface area of cylinder A, I'm going to take this number here and this number here and add them together. So I want you to notice they both have the pi. So I'm just going to add the 126 plus the 98, and that is giving me 224 pi meters squared. Okay. Now we're going to do the same thing for part B. For part B, I'm going to find the area of the top and bottom. It's going to be 2 pi r squared. So 2 pi, the radius in this case was 9. Oops, getting ahead of myself. 9 meters squared. So it's going to be 2 pi times 81 meters squared. So 2 times 81 is going to give me 162 pi meters squared. So now to find my surface area, I'm going to take this number here, and, oops, I already had my equal sign, and add them together. Oops, come on, eraser. There we go. Okay, so let me take my calculator again. Let me bring this back this way. So 126 plus 162, that's giving me 288 pi meters squared. Okay, so here's the surface area for B. So 288 is B, 224 is for A. Which one is bigger? Cylinder B. Okay. All right. Excuse me. So the next question here says, what happens to the surface area of a sphere if the radius is doubled? Okay, so let's see if we can figure this out. So remember, my formula for surface area is 4 pi r squared. And what we're trying to figure out is what happens if we double the radius. Okay. So 2 pi, or 2r, I'm sorry, squared is going to give me 4 r squared, and 4 times 4 is going to give me 16 pi r squared. So now what I'm going to do is I'm going to do a comparison. Here's my original one. Here's the one that we have now. What happened to the surface area? What did I have to multiply 4 by to get 16? We had to multiply it by 4. So we would say it is quadrupled, or 4 times as big. Okay. Now let's do the same thing for part B. My formula is always 4 pi r squared. Okay, and now we are tripling it. Okay, 4 pi. So what does that mean? That means that the radius is 3 times as big as what it used to be. Okay, so 3r when you square it is going to give me 9r squared. 9 times 4 is 36 pi r squared. So again, I'm going to do a comparison. Look, here I have 4. Here I have 36. It is 9 times bigger, right? Okie dokie. So now let's take a look at this next problem. Let's see if we can't figure it out. It says approximately How much material is needed to make the tent illustrated in the figure to the right? It says both ends and the bottom should be included. Okay, so let's see if we can find, tell you what, let's see if we can find this piece. Remember, there's two of them. There's this one here, and there's the one over there. So I know this piece here is 8. What I don't know right now, I don't know this piece, okay? So couldn't we use the Pythagorean theorem? If we know that this whole distance here is 6, then from here to here, it's going to have to be 3. So if I wanted to find this distance here, that would be my hypotenuse. So I'm going to move this over here so I can do this on the side. So remember, my Pythagorean theorem, a squared plus b squared equals c squared. So let's call this a and let's call this b. So 3 squared plus 5 squared equals c squared. So that's 9 plus 25 equals c squared. So 9 plus 25 is 34 equals c squared. So c is equal to the square root of 34. Okay, not a nice pretty number, but that's just what it is. Okay, so I'm going to take this distance here and this distance here to find the area, and there's two of them. Okay, so we're looking for the surface area. So we're going to take length times width, okay, which is going to be 8 times the square root of 34, and there's two of them. So I got to multiply this by 2. So 2 times 8 is 16, square root of 34, and this is in feet squared. So we've taken care of, say, the sides. Now let's do the front and the back, the triangle part, okay? So front and back. Okay, so remember the formula for the area of a triangle is 1/2 base times the height. So half the base times 6 times 5, that's going to give me half of 30, which is 15 square feet. But because we have two of them, now I got to double it. So the front and back is, if we double this, it's going to be 30 square feet. Okay. So we have the sides, right? Right here, 16 times the square root of 34 square feet. We have the front and the back. Now we need to do the bottom. So the bottom is going to be this rectangle right here, okay? So one side is 8, one side is 6. So the bottom, length times width again. So 8 times 6 is 48 square feet. Now there's no top to it, right? So it's just at 48 square feet. So now, to find our surface area, we're going to take 30 plus 48 plus 16 square root of 34. We're going to add those together. These I can add. That's going to give me 78 plus 16 square root, 16 square root of 34. I'm going to write this in parentheses, guys, because my units here are going to be in square feet, okay? Square feet. Alrighty. So let's see if we can figure out what's happening in this next problem. So it says, determine how the lateral surface area of a right circular cylinder changes if the following transformations are applied. Part A says the radius is quartered, and part B says the height of the cylinder is quartered. Okay, so remember, when we're finding a cylinder, okay, like this, and we're looking only for the lateral surface area, let's think about again what that means. That means I'm going to cut this thing down, and I'm going to open it up like this, right? And that's going to be my height, and this distance will be my circumference, right? So the lateral area here would be 2 pi r times h, okay? So part A says, what happens if we quarter the radius? What does that mean? That means that the radius is 1/4 of what it used to be. So if this was my formula before, the lateral area, and it's 2 pi r times h, right? And we're going to quarter the radius. So 2 pi times 1/4 of the radius h. Okay. So let's see. This is going to be 2 over 4 pi rh, and that's going to be 1/2 pi rh. Okay. So what happened here? What happened to my original formula, right? So if I look at this piece here and look at this piece here, you might be tempted to say, oh, look, it's half of it. But it's not really half of it. What we did is if you were to take 2 pi rh and you were to divide it by 4, and these would reduce here to a 1 and a 2, that's what I'd end up with, right? So we really said the lateral surface area is going to be quartered, okay? All right, now it says, how does the lateral surface area change when the height is quartered, okay? So remember, my formula is lateral area equals 2 pi rh, okay? And now it's saying, what happens if the height is quartered? So we're going to have 2 pi r h over 4, and this is going to give me 2 over 4 pi r and h, which is still going to be 1/2 pi rh. And so my lateral area is still going to be quartered, okay? Alrighty. So the next problem here says, a gas storage tank is in the shape of a right circular cylinder. So I'm going to stop right there. I'm going to draw a picture. Here's my right circular cylinder. And it has a radius of the base of 3 feet. So this distance here is 3 feet. And that's also 3 feet. The farmer wants to paint the tank including both bases, but only has 1 gallon of paint. If 1 gallon of paint will cover 211 square feet, will the farmer have enough to complete the job? I don't know. Let's see if we can figure it out. We're looking here for the surface area, okay? So let's see if we can find the surface area. So remember the formula for the surface area? If you forgot, that's okay. I'm going to come back over here, and we're going to look for it. And for a cone, for a cylinder, I'm sorry, here we go. Surface area is 2 pi r squared plus 2 pi rh. So 2 pi r squared plus 2 pi rh. Where are we? Here we go. 2 pi r squared plus 2 pi, pi rh. Okay. So all we're going to do now, we're going to do a little plug and chug, okay? So 2 pi, my radius is 3 squared. 2 pi, my radius is 3. My height is also 3. So 2 pi, 3 squared is 9. Plus 2 pi, this is also 9. So 2 times 9, this is 18 pi. Plus another 18 pi. So 18 and 18 is... what, 36 pi, and my units are in feet, so this is feet squared. We're looking to try to figure out, are we going to have enough paint, right? And so we know that the paint covers, 1 gallon covers 211 square feet. So at this point here, guys, what I'm going to do, I'm going to use an approximation here, because I'm trying to figure out, is the area of this thing here, top and bottom, is that more or less than 211? So let me grab my calculator. I'm going to turn it back on. What is 36 times 3.14? And I'm coming up with 113.04. That's how much area we have. We have 1 gallon of paint. 1 gallon covers 211. We only need 113. Do we have enough paint? Yes, we do. Okay. Alrighty. So I got another problem here, and it says a pyramid-shaped building is 340 feet tall and has a square base with sides of 613 feet. The sides of the building are made from reflective glass. What is the surface area of the reflective glass? Okay, so I'm going to try to draw this as best I can. And sorry, my pen is freezing again. Trying to make this as much of a square as I can here, guys. Oops, I already messed it up. Okay, let's come back. There we go. That's pretty squarish. Okay, I'm going to put a top right here. And let's see, boom, and boom, and okay, come on, you got another one. Boom. Okay, so we know that the sides are 613 all the way across. Okay, and we know that the height of the building is 340. Okay, so that means that there's a line that's going to go right here. Come on now. Okay, and so I know that this distance, come on, pen, right there is 340. Okay, what I need to find out is what is this distance going to be right here. So one thing I want to point out, if this whole piece is, of the whole side down here on the bottom is 613, that should be half of 613, right? Oh man, why couldn't they give us an even number? That's okay. 613 divided by 2. 306.5. We're just going to deal with it. 306.5. Okay. So now I'm trying to find this distance here. That's going to be my hypotenuse, right? So my a squared, b squared equals c squared. Come on now. Come on, pen. C squared. Okay. So let's call this a. Sorry about that. Let's call this a and let's call this b. So I'm going to take 306.5 squared. B is going to be 340 squared equals c squared. So let's get our calculator. 306.5 squared plus 340 squared is that number there, and I need to take the square root of it, okay? Because I'm doing my Pythagorean theorem of the answer. Okay, and here we go. Okay, so I'm coming up with 457. Oops, 457. I'm going to say 7579. Now, I want you to notice something here. It's kind of in the background right here, but it says round all intermediate values to 4 decimal places as needed. That's why I stopped at the 79, okay? So now, excuse me, now we know this distance here, okay? So I want to find the area of this triangle, okay? So the formula is 1/2 base times height. So this is going to be 1/2. The base is 613 times the height, which was 457.7579. Okay. And I'm going to take my calculator and I'm just going to multiply these numbers out. So I'm going to say, what is 613 times 457.7579 equals, okay. I'm going to divide that number by 2 equals, okay, so the area that I'm coming up with is 14302. 7964. Okay, and this is in feet squared, I want to say, because it should be given to us in feet. Yes, it is in feet. Sorry about this, guys. Feet squared. Okay, so we just found the area of this side. How many sides do we have, though? We have 4. Okay, so now I'm going to take 4 times this number right here. Okay, Okay, so times 4. And now I'm coming up with 561 to 11. And it says write the final answer to the nearest whole number. Okay, so the reason I'm stopping right there is, if you notice, if I go to the nearest whole number, it would be 561 to 11, right? Because after that point, we have a 1. So this here would be feet squared. Now, one thing I want to point out about this particular problem, it was asking me for the surface area of the reflective glass. Notice here how I wrote lateral area, because the glass are the sides, okay? There's no glass on the floor, right? It's just the side. So it was really finding a lateral area type problem. So when you're doing this problem, just be careful, because it does say surface area, but it really is a lateral area type problem, all right? And that right there, guys, was 13.4.